They were the linebackers of the Pleistocene. Short, stocky, with a muscle mass that dwarfed our own. For 300,000 years, the Neanderthal was the undisputed king of the cold. But when the climate shifted, their perfect body became a fatal flaw. Neanderthals were not just our cousins, they were biological tanks, barrel chests, massive limbs, built like linebackers designed for Ice Age survival. Yet they vanished completely while we thrived. The shocking truth? Their superior body was actually their death sentence. Those muscles that made them unstoppable hunters became the very thing that killed them.
We're talking about a caloric crisis so severe it drove the strongest humans in history to extinction.
To understand why the Neanderthal body was both magnificent and fatal, think of it as an evolutionary Ferrari. Perfectly engineered, incredibly powerful, but absolutely devastating on fuel consumption. The numbers tell the story. Recent studies estimate that adult male Neanderthals required between 3,800 and 4,500 calories every single day just to survive. Compare that to early Homo sapiens living in the same environments, who needed roughly 2,400 to 3,000 calories daily. That is a 50% difference in basic energy requirements. But why were they burning through so much fuel?
Start with the chassis.
The average Neanderthal male stood about 5 feet 5 inches and weighed around 165 pounds of muscle and dense bone. Their skeletons were massively robust, with cortical bone thickness that would make a modern powerlifter jealous. Every movement required more energy because they were literally carrying more weight. Then there is the engine, their cardiovascular system. Neanderthal rib cages were shorter, deeper, and wider than ours. Think barrel-chested, taken to an extreme.
3D reconstructions of Neanderthal skeletons show lung capacities of over 9 liters. Modern humans average about 6 liters.
That massive respiratory system was constantly working overtime, burning calories to process the oxygen needed for their oversized bodies. The most energy-hungry component was their limb design. Neanderthals had what scientists call low crural indices, meaning their lower leg bones were short relative to their thighs. This body plan follows Allen's rule perfectly.
Short extremities retain heat in cold climates, which was brilliant for Ice Age survival.
But here's the fatal trade-off. Shorter limbs are metabolically expensive for locomotion. Every step a Neanderthal took burned 20 to 30% more calories than the same step taken by Homo sapiens. During the winter months, when temperatures dropped and resources became scarce, this became a death spiral. While Homo sapiens could tighten their belts and reduce activity, Neanderthals were trapped by their own biology. Their massive frames demanded constant fuel regardless of availability.
The most vulnerable members weren't the adults. They were the children.
Neanderthal infants were born with the same barrel-chested, robust body plan already locked in place. This was not a response to cold stress during development. They were genetically programmed to be metabolic furnaces from birth. Research on Neanderthal growth patterns reveals something terrifying for population survival. During the critical years between ages 3 to 6, when modern human children are relatively efficient, Neanderthal children were caloric black holes. Their developing brains, larger than ours, combined with their robust, energy-hungry bodies, created a perfect storm of resource demand. Think about that from a group survival perspective. In harsh winters or resource crashes, every Neanderthal child represented a massive investment that might not pay off. Meanwhile, Homo sapiens children required less food and developed more quickly into productive group members. The evidence comes from skeletal analysis of growth rates and bone chemistry. Neanderthal bones show stress markers indicating frequent periods of nutritional inadequacy during development.
These weren't isolated incidents. They were systematic patterns suggesting that Neanderthal communities regularly struggled to meet the caloric demands of their own children.
This biological Ferrari was perfectly designed for stable, resource-rich environments. But when the fuel supply became unpredictable, That magnificent engine became a liability that would ultimately drive them to extinction. The Neanderthals' energy-hungry body might have survived indefinitely in a stable world. But the late Pleistocene was anything but stable. From 70,000 to 30,000 years ago, Europe experienced some of the most chaotic climate swings in Earth's history. These were not gradual changes over thousands of years. We are talking about temperature shifts of 15 degrees Celsius happening within decades. Scientists call them Dansgaard-Oeschger events, rapid oscillations between warm and cold periods that could flip entire ecosystems in a human lifetime. Picture this. You are a Neanderthal group living through what seems like a mild period. Forests are expanding, large herbivores are thriving, and your high-calorie hunting strategy is working perfectly. Then, within 20 years, temperatures plummet, the forests disappear. Your prey animals either migrate south or die off entirely. For Homo sapiens, this was manageable. Their lower metabolic demands meant they could survive on smaller prey, plant foods, and even aquatic resources when necessary. They were dietary generalists with the flexibility to adapt. But Neanderthals were trapped by their own success. Isotopic analysis of Neanderthal bones reveals they were hypercarnivores. Their diet consisted almost entirely of large terrestrial mammals: mammoth, woolly rhinoceros, reindeer, bison. These were the only prey species that provided enough calories to fuel their massive bodies. When the Heinrich event struck, massive iceberg discharges that sent temperatures crashing across Europe, the megafauna populations collapsed. Archaeological evidence from this period shows a devastating pattern. Sites that once yielded massive bone assemblages suddenly contain only fragments, processed down to extract every last calorie.
The site of Aberch Pizarro in Spain provides a haunting glimpse into Neanderthal desperation during these resource crashes.
Over 246,000 animal bone fragments show intensive processing that goes beyond normal butchering. Bones were systematically smashed to access marrow. Spiral fractures indicate they were breaking fresh bones, not scavenged remains, suggesting they were consuming everything immediately rather than storing food for later. This wasn't occasional scarcity. This was systematic starvation. The mathematics was brutal. When prey density dropped by 40% during climate crashes, Homo sapiens could reduce their activity levels and survive on alternative foods. But Neanderthals faced a horrible equation. Their bodies still demanded 4,500 calories daily, but their primary food sources had vanished. The refugia, where both species took shelter during the worst climate events, became pressure cookers of competition. Archaeological evidence shows that in regions with stable, high productivity, like the Danube Basin, Neanderthals and Homo sapiens coexisted for thousands of years. But in marginal areas, where resources were already stretched thin, Neanderthals disappeared immediately after Homo sapiens arrived. The demographic consequences were devastating.
Neanderthal populations were already small. Genetic evidence suggests effective population sizes in the low thousands across their entire range.
When climate chaos struck, they could not afford to lose even a few individuals to starvation or failed hunts. Meanwhile, Homo sapiens populations were growing and expanding precisely because their lower energy requirements allowed them to maintain larger, more stable communities even during resource stress. The Neanderthals' massive physique wasn't just expensive to maintain. It locked them into a hunting strategy that became impossible when their world changed. Archaeological evidence from sites dated to 120,000 years ago reveals the Neanderthal hunting method: close-range ambush with thrusting spears. Ballistic analysis of puncture wounds on ancient prey bones confirms they had to get within arm's reach of dangerous animals like aurochs and woolly rhinoceros.
This approach worked brilliantly when megafauna were abundant.
Neanderthal groups could afford the high-risk, high-reward strategy because successful kills provided massive caloric payoffs. A single mammoth could feed a group for weeks, but the cost was enormous.
Skeletal trauma analysis shows that 80% of Neanderthal remains exhibit healed fractures consistent with close contact hunting injuries. These weren't occasional accidents. They were occupational hazards.
Every hunt meant risking traumatic injury that could remove a hunter from the group for months. Compare this to the Homo sapiens approach. By 45,000 years ago, they possessed sophisticated projectile technology, spear throwers, and eventually bows that could kill large prey from 50 meters away. This was not just safer, it was metabolically efficient. Less energy expenditure per hunt, lower injury risk, and the ability to target smaller, more numerous prey when megafauna became scarce. The dietary isotope data tells the story. Neanderthals maintained the isotopic signatures of top-level carnivores throughout their existence. They never adapted to exploit smaller prey or plant resources effectively. Meanwhile, Homo sapiens show isotopic evidence for dietary flexibility. Large game when available, small game and fish when necessary, even marine resources in coastal areas. When climate chaos fragmented the megafauna populations that Neanderthals depended on, their hunting strategy became their death sentence. They lacked the tools and techniques to efficiently exploit the smaller, more diverse prey that could have sustained them through the crisis. The final irony is that their powerful bodies, perfectly designed for wrestling down massive prey, became useless in a world where success required precision, range, and adaptability, rather than raw strength. The Neanderthal extinction was not about intelligence or culture, it was about energy economics in a rapidly changing world.
Their greatest evolutionary achievement, a body perfectly adapted to Ice Age hunting, became their fatal weakness when the climate shifted and competitors arrived.
They were not conquered by superior humans. They were outcompeted by more efficient ones. Every calorie that built their impressive muscles was a calorie that could not support population growth or technological innovation. In the end, the muscle that made them mighty was the muscle that killed them.
The Neanderthal story isn't just ancient history. It's a reminder that survival isn't about being the strongest or most specialized. Sometimes the greatest evolutionary advantage is simply being efficient enough to adapt when the world changes. If this deep dive into the hidden mechanics of human extinction left you questioning what other secrets are buried in our evolutionary past, don't let the story end here. Like this video and subscribe to uncover more of the uncomfortable truths about what it really takes to survive as a species.